Hey, what's up, everyone? Welcome back to another video that I'm hosting today. And today we're going to talk a little bit about things that trip on a lot of network engineers when they try to scale out Cisco ISE in a radius load balancing scenario. So if you have a handful of policy service nodes or PSNs and you're trying to distribute radius across devices without making sure you don't break 802.1x, change of authorizations or session tracking, this episode is for you. And we're basically basing all this information in the Cisco's official knowledge base guide on radius load balancing for ICE. And I'm gonna walk you through every major concept in about 15 minutes, so let's get into it. For this part of the video, I want to make sure that we talk a little bit about some key concepts and terminology. So before we jump into any configurations, let's lock down on some vocabulary because Cisco uses specific terms throughout this guide and you will need to know them just to follow along on what we're doing. But the first one we're going to start is the PSN or the Policy Service Node. This is the ICE persona that actually handles radius requests and makes the policy's decisions. If you're doing profiling, the PSN handles that information too. And in a load balance setup, you have multiple PSNs behind a virtual IP. Next thing is going to be the VIP or the virtual IP address. And this is the address that the load balancer listens on. Your NAT or network access devices, your switches, wireless controllers point to the VIP as the radio server. The load balancer then forwards those packets to those real PSN IP addresses in the backend. What is a NAT? It's a network access device. And this is basically your access layer gear, switches, wireless LAN controllers, firewalls, and anything that enforces the access and sends radius authentication requests. Backend pool, it's another concept, or server farm. And this is just a grouping of PSNs that will receive the traffic forwarded from the VIPs. Think of this like a cluster of real servers behind a single front-end address. I want you to know this as a tip. Group PSNs geographically, just like if you configure ICE nodes in groups. Cisco recommends using your ICE nodes group structure as the basis of your backend pools. And this will allow you to keep session data shared between the nodes in the same location. Next is going to be the protocol basics. Here's something that catches people off guard when they run radios over UDP, not TCP. And that matters a lot when choosing a load balancer. And it is just by design. Radius authentication and authorization uses UDP on port 1812, and the radius accounting uses UDP on port 1813. So if you're also load balancing TACAX plus traffic, that's going to be on port 49. Now, most of the cloud load balancers come in two flavors. One of them is the application load balancers and then the network load balancers. Application load balancers don't process UDP at all. So right off the bat, those are out of the equation. You want a network load balancer and you need to confirm it explicitly that supports UDP traffic. And then the second part to this is a listener. Listener tells the load balancer which port to watch and where to write traffic to. So if you virtual IP, which is, let's say, for example, 192.168.100.100, a listener on the UDP 1812 means any radius authorization packets are hitting that IP and then getting forward to your backend PSN pool. Any traffic with no matching listener gets dropped, just full stop. Let's go over a few of the load balancing methods. And we're going to talk about how traffic actually gets distributed. With radius, you need to be careful because UDP is connectionless, and any method that relies on tracking an ongoing TCP connection is off the table. Now we're going to talk about the session persistent. ICE requires that all radius packets for a given session go to the same PSN. Authentication, authorization, accounting, and any follow-up transaction like re-authentication after a change of authorization, it's also on the same pattern. If packets from the same device hit two different PSNs, ICE can manage the session lifecycle properly and things start to break. have an image here that goes over a little bit of that. And then we're also using the calling station ID. So let's talk about that. And in this case, most guys recommend using the calling station ID, and that is going to be the client MAC address as your persistence key. For standard 802.1x authorization, this works great because attribute 31 is always present. Now, what is the NAS IP as fallback? There's a real world gotcha. Some Redis packets like TrustSec, pack provisioning don't include attribute 31. The fix is a compound persistence key on both the attribute 31, which is the calling station ID, and the attribute 4, which is going to be your NAS IP address. Using F5's load balancer, our rule implementation handles this, but built in the back logic. Also, it's important that the timeout value on the persistent rules need to be long enough to cover your full reauthentication cycle. The default 2 minutes is way too short, and Cisco recommends setting it at least 1 hour beyond your highest reauthentication timer. Next, we're going to go over health monitoring. And in this case, your load balancer needs to know which PSNs are actually healthy before forwarding traffic to them. Then just ping a port or just check an open UDP socket. That won't tell us if Radius is actually responding. If you want a load balancer to send real Radius test authentication requests to each PSN periodically. F5 Big IP LTM has a built-in Radius health monitor that does exactly this. And it acts as a simulated Radius client, sends an authorization authentication request with a test username and a password, and then it just checks for response. Now, for this to work, you need to add the load balancer as a network access device in ISE. So in this case, ISE will respond to those probe authentications. How do you get to that? You navigate to administration, network resources, network devices, add and enter the load balancer's IP address. And when a PSN fails its health check, the load balancer automatically pulls it from the pool. And a change of authorization is triggered from another node into the same node group, forcing the affected sessions to renegotiate to a healthy PSN. Now let's talk about the SNAT problem or source NAT. And here's just a concept that everybody gets stripped off over. And then in this case, source NAT is a fantastic in a lot of load balancing. It's a fantastic tool in a lot of balancing scenarios. It simplifies the return part routing, but with ICE, don't use it on a NAT to PSN path. Here's why. ICE identifies NATs by either their IP, their layer 3 source IP address, and if you SNAT the traffic from a switch through the load balancer, the PSN sees the load balancer's IP as the source, not the switch's real IP address. And this is going to break the NAT identification, which breaks policy lookups and change of authorization. The correct mode in this case is using routed mode, also called transparent mode or pass-through mode. Depending on your vendor, the load balancer forwards the traffic while preserving the original source IP. Now, there is some exceptions. Some vendors like Citrix NetScaler support RNAT or reverse NAT for COA traffic going from the PSN back to the NAT. This can simplify NAT config by just letting COA use the virtual IP, but never configure RNAT in the NAT to PSN direction. Let's talk about some of the requirements from the Cisco ISE perspective configuration. We're going to need a NAT configured, and on every NAT, every switch in WLC or wireless LAN controller needs to point to a radio server configuration at the VIP. But the change of authorization, you configure each PSN's real IP address individually on the NAT. So in this case, COA traffic bypasses the load balancer entirely. PSN direct reachability. This is critical. Every PSN must be directly reachable from 3 places. The administration node and the monitoring nodes for the administration and logging as well. Endpoints for web redirects, central web authentication, and posture assessment, and accounting messages from network devices must reach the PSNs directly, not through NAT. Next thing is going to be a certificate. And what you want to do is make sure that you include the VIP's fully qualified domain name in the subject alternative name field for the PSN certificates. That way, when a client presents to the VIP and gets redirected to the PSN, the certificate is going to validate it correctly. Another key term and another thing that you need to configure is going to be the node groups. This is going to be just to make sure that you map your ICE node groups to your load balancer backend pools. Again, same geographical grouping, same set of nodes. And if a PSN fails and another node in the group initiates a COA or a change of authentication or authorization, the load balancer routes the new request to a healthy node in the same pool. Cloud load balancers, and you will see this in more organizations. And as everybody's starting to move to the cloud or they're in the process of doing it, the question of cloud-based load balancers for radios has come up a lot. And the fundamentals are exactly the same. You still need UDP support, session persistence, and routing mode. Now, the key thing to verify any cloud load balancers is whether it supports UDP. Most application load balancers in cloud environments do not support it. So you want to make sure that you have a network load balancer tier specifically, and you need to confirm UDP protocol support before getting down the path. The Cisco guide covers several specific cloud load balancer platforms in detail, showing a step-by-step config for each. And in this case, the concepts we are covering today apply across all of them. Listeners is going to be 1812 and 1813 for the ports, persistent keyed on the calling station ID with NAS IP fallback, no source NAT, and help probes that actually test radios. Those are important. All right, and this is just to wrap the session about load balancers and Cisco ISE. Here are a few key things that I want you to take away from this video. Number one, always make sure that you use a network load balancer with UDP support. Remember, application load balancers won't work with radios. Number two, configure listeners on UDP 1812 and 1813. Add TCP49 if you're also doing TACAX Plus. Next thing is going to be make sure to enable session persistence. Key on the calling station ID with NAS IP as your fallback. Set the timer well beyond your reauthentication interval. Number four is going to be never use SNAT the NAT to PS in the NAT to PSN path. Use the transparent or routed mode. SNAT breaks NAT identification and kills the change of authorization. Number five, configure your COAs using the real PSN IPs and NATs, not the VIP. Number six is going to be to set up the real radius health probes on your load balancer, not just the port checks. Add the load balancer as an ad in ICE so probes can actually authenticate. Number seven, align your backend pools with Cisco ISE node groups using the same geographic locations and same failover behavior. And for number eight, if you're running Trustic, test the pack provision specifically. It doesn't include the calling station ID, so you need compound persistence or you will see random failures. And that is everything I had for you today on Cisco ISE and load balancers. Just exploring some of the concepts, and I hope you liked the video.